They make up an army of incredible machines. A rig that drills wells several kilometers underwater. A ship that lays pipeline on the ocean floor. And an immense gas processing platform designed to float in the stormy Gulf of Mexico. They're all part of a daring plan to build a network of natural gas wells and pipelines in deeper water than ever before, 2,700 meters down. And hurricane season is on the way. For this team of mega movers, there's no time to lose. Beneath the waters of the Gulf of Mexico lie some of the world's richest natural gas fields. And an ambitious plan is underway to harvest that energy from the ground. It's called the Independence Project. The goal is to drill wells and lay pipeline to get the natural gas to a central processing platform and from there to shore, where it will be sold. Natural gas networks have been around for a long time, but no project's ever been attempted in water this deep. For years, thousands of underwater wells have lined the shallow waters of the Gulf of Mexico. They supply 20% of the natural gas used for cooking and heating in the United States. But demand continues to grow, and the wells in the Gulf are already working at capacity. Energy companies have known for a long time that gas reserves exist in the Gulf's deep waters. But the technology hasn't existed to drill there beyond the continental shelf and 2,700 meters down until recently. It's the most daring effort yet in the race to harness more energy from the deep sea. A team of mega machines has already been hard at work for months, building a vast deep-sea gas network. They have 5 main challenges to meet. The first is to drill 15 wells through more than 3 kilometers of water and 4 kilometers of sea floor in a 4,600 square kilometer gas field. Then they have to lay pipeline connecting each well to a central processing platform. They must install cables along the pipeline so that engineers on the platform can control the flow of gas from each well. They have to drive massive pilings to anchor the central processing platform to the ocean floor. And finally, they must build a huge pipeline to deliver the gas from the processing platform 135 miles to land. Construction on the processing platform is underway at Ingleside, Texas. Once it's installed in the open ocean, this platform will be the hub of the network, purifying the natural gas and sending it back to shore. But first, the gas network has to be built. And that will require a team of mega movers. The Deepwater Millennium will tackle the first job, drilling the wells. Next, the Loreley will build a network of pipelines to connect the wells to the central platform. The Toyser Perseus will run control cables along the pipeline. And only one ship can tackle the next step, building the monster pipeline to the shoreline, the Solitaire. Installing the huge anchor pilings is the job of the Boulder. Meanwhile, another team of mega machines is constructing the massive gas processing platform more than 70 meters wide. In order to float above the gas fields in the Gulf, it has to be attached to this huge 4-towered hull, en route aboard an amazing ship, the mighty Servant 3. Mounting the huge platform in the hull will involve one of the heaviest lifts ever performed. And that's when this crane-like heavy lift device will swing into action. To get the network up and running, each of these machines will have to do its job perfectly. But Mother Nature can wreak havoc on even the best laid plans. The Gulf of Mexico is notorious for powerful storms, and summer is peak hurricane season. 7 major storms made 2005 the worst hurricane season on record and the most devastating in memory. And this year could be even worse. The first job is to get the gas wells up and running. Months ago, the Deepwater Millennium drilled the wells for the project. The ship's drilled pipe had to reach 2,700 meters down to the sea floor and dig in. Then it had to punch through another 5 kilometers of sea floor to reach pockets of natural gas, an incredible 8 kilometers below the water's surface. Now the Deepwater Millennium will finally answer the $2 billion question. Will enough gas flow freely to make this well worth tapping? To test the gas flow, the ship must gently lower this delicate column of valves and sensors to the bottom of the well. The Millennium is perfectly designed for the job. She's a drill ship. At 221 meters, she stretches longer than 2 football pitches. A huge tower on her deck, called a derrick, will lift the column and lower it into the water through a hole in the middle of the ship. The column will descend to the well through this pipe, almost 2,700 meters of steel tubing that stretches from the ocean surface all the way to the top of the well. Once the testing equipment's installed in the well, engineers on the ship can determine if natural gas is flowing freely. The Millennium's crew prepares to lower the testing column into the well pipe.
You might be able to bump it out some more, Jason.
It takes a delicate touch.
Is it all the way out?
If the column hits anything, it could damage the critical seals that keep gas in and water out.
Right, watch your fingers, Harley. There's a bunch of places you can get bit.
The crew lines up the column at the top of the well pipe and begins to lower it.
I got buttons like, oh.
But suddenly, it stops descending. A jammed column could mean costly delays.
If we change that assembly out, then you're probably looking at 10 to 12 hours.
Get ready to tell him to stop. If we start stroking his lock, man, I don't want him to stop. Stop. Stop.
The crew examines the column to work out what's gone wrong. It refuses to budge. They try to wiggle the test column gently.
That's it. Look, what you got to do is you got to push it that way.
Starting now.
You want to watch this lock mandrel?
There it goes. We got it.
It does the trick, and the column finally slides into place.
There you go. You want to verify that in the book?
It'll take 2 days for the testing equipment to reach its destination.
Put it up.
And that means 2 days before the crew can answer the critical question. Will a well drilled in the deepest water yet actually work? The Deepwater Millennium hovers above a gas well in the Gulf of Mexico. After several setbacks and delays, the crew finally gets the sign they've been waiting for. The testing equipment has reached the well 2,700 meters down. It's now time to see if the well can produce for the Deep Sea Independence Project. With the touch of a computer screen, engineers open the valves deep inside the well and gas begins to flow. The crew monitors every sensor and valve. The test is a success. gas flows freely from the well. The Millennium has successfully got 15 wells up and running. Now it's time for step 2, laying the pipeline that will connect each well to the processing platform. A vast network of pipes has to be laid precisely on the sea floor. A new mega mover now takes charge. The All Seas Loreley is a pipeline building professional. At 180 meters, she's longer than the Washington Monument is tall. A massive pipe manufacturing facility fills nearly 2/3 of her hull. Off her stern, a 61-meter guide called a stinger lowers the pipeline to the sea floor. Creating this network of pipelines is like building a sewer system nearly 3 kilometers below the ocean's surface. The Loreley's biggest challenge is to lay each of the pipelines on its predefined pathway. If she deviates even a few centimeters, the result could be a massive tangle of steel. The Loreley has just a few months to complete the task before the gas processing platform arrives, and summer is prime time for hurricanes. She has to lay the pipe before bad weather catches up to her. Below her decks is a massive hold containing nearly 10,000 kilograms of steel pipe. The pipes can't be welded at the bottom of the ocean, so that part of the process happens here, in a high-tech assembly process called the firing line. Massive lifts carry 12-meter sections from the hold and slide them into the firing line. These pipes will then be connected to form a single pipeline 72 kilometers long. Amazingly, even steel pipe over 2 centimeters thick bends like a garden hose under its own weight. 3,600 meters of pipe are suspended between the ship and the sea floor in a giant curve. The Loreley works around the clock and can produce up to 4 kilometers of pipeline every day. This makes her one of the fastest pipe-laying vessels in the world. With the wells and pipeline construction underway, it's now time for step 3. The cables that will control each well's gas flow must be laid, and that's a job for the Toysa Perseus. She's one of the only vessels capable of performing this task in such deep water. Her huge reels hold several kilometers of the thick cables, and her aft deck is bigger than 3 basketball courts. It needs to be, because that's where the Perseus carries her giant cable connectors. The crew places a connector next to each well, and then runs a cable along the pipeline all the way back to the processing hub. These cables are an essential part of the network. By supplying the electronic and hydraulic power to open and close the well's valves, they'll allow an engineer on the processing platform to control the flow of gas from a well as far as 72 kilometers away. The first step is to carefully spin the cable out of the hold. Below deck, this massive reel holds the longest control cable of the project, 21 kilometers long and weighing over 1,000 tons. The end of the cable is threaded into a curved guide to prevent kinking the delicate internal elements. It's a tricky maneuver that requires handing off the cable between the 2 cranes. Safely in the guide, it's lowered to the deck. Workers attach a stabbing pin to the end of the control cable. Then they must lock the pin into the connector already installed on the sea floor. It's just like putting a plug into a socket, except the cord is nearly 3 kilometers long. two huge tensioners close in on the cable. Their tractor-like grip holds the entire weight of the cable as it's lowered. It's a straight shot through a hole in the middle of the ship, 2,700 meters down. And that's where the real challenge begins, plugging the pin into the bucket-sized socket. Once the cable's in the water, there's no turning back.
Okay, coming down. Okay, coming down.
After a 4-hour journey, the moment of truth is at hand.
The stab point for us.
The cable lowers to the sea floor, 3 meters from the connector. ROVs, or remotely operated vehicles, are the engineers' eyes and hands on the sea floor. They're launched from the ship at the start of every underwater operation. Without them, engineers couldn't plug in the control cable.
Stuart, do you happen to see that mud mat in front of you there?
The crew steers the Toyser Perseus and the plug dangling far below, closer to the metal structure. If it hits and they damage the high-tech plug, this multi-million-dollar cable will be nothing but scrap on the bottom of the sea.
Ready to try and stab this?
Inserting the stabbing pin at the end of the cable into the small socket in the connector is a real challenge. It's like trying to thread a needle from a distance of 2,700 meters. The Perseus and the entire team of Mega Movers are able to stay exactly on target because of one particular piece of technology: dynamic positioning. Computers measure every factor affecting the ship's position and control the engines so it can hover in one spot or move forwards, backwards, or even sideways.
Fly it over the stab point for us.
On the bridge of the Perseus, workers rely on an ROV to guide the stabbing pin towards its target.
Then it clockwise 90 for it.
The pin is in, but it won't lock.
Oh, and just put it on the swivel plate and tried to push the swivel plate around.
It's turned out of position, and there's nothing the ROV can do to turn it back. Without a perfect connection, the cable will be useless.
BLS bridge, come up 1 meter.
The crew comes up with a clever strategy. Workers enter a new heading for the Perseus. Then, as the ship rotates, it swivels the cable, turning the stabbing pin on its axis.
Yeah, we've put 1 meter of slack in it.
The plan works.
Yeah, roger, I'll stop on it.
The pin finally locks into the socket.
Okay, can you follow it over and just watch the touchdown for me?
With the hardest part of the mission accomplished, the Perseus can now lay the long cable that will control the flow of gas from the well. The Mega Movers have successfully tackled 3 of the 5 major projects facing them. They've tested the 15 wells, laid 338 kilometers of pipe to bring the gas to the processing platform, and installed control cables throughout the network. But a major step still remains: building the giant pipeline to get the gas to shore. It will take almost 20,000 pipes and months of work to construct the 217-kilometer Independence Trail. And there's only one ship in the world strong enough to build it, the All-Seas Solitaire. She has to lay this huge pipeline before the processing hub can pump gas. Few vessels would dare to attempt this mission, but the Solitaire is not just any ship. She's the largest pipe-laying vessel in the world. At 365 meters, the Eiffel Tower could easily lay on her deck. A pipe welding assembly line runs the entire length of the ship, and a huge stinger juts from her stern to guide the pipeline to the sea floor. Like the Loreley, the other pipe-laying ship in the project, the Solitaire builds the pipeline in one continuous motion, welding the pipes together inside her hull, then depositing the finished pipeline on the sea floor. But unlike the other ship, the Solitaire does this on a much bigger scale. Her 6 cavernous holds carry over 21,000 tons of pipe, more than the weight of 120 jumbo jets. But even this quantity of pipe doesn't last long. Solitaire can lay 6 kilometers of pipe in a day. Huge barges constantly replenish the supply of pipes to keep her busy. And that's when the ship's cranes swing into action. Most cranes have a single long boom, but these monsters have 2 arms, giving them amazing accuracy and speed. To complete the Independence project on schedule, the Solitaire has to build and lay the pipeline fast. First, workers mill the pipe's ends to provide a smooth, clean surface. Then the pipes are welded together at 8 welding stations. Each weld adds more strength to the joint. A special drone even welds the seam inside the huge pipe. The completed pipeline will contain more than 21,000 welds. When every station is ready, a bell rings and the pipe seems to move out the back of the ship and into the sea. But this is what really happens. The several kilometers of pipe on the sea floor connect directly to the ship like a massive anchor. Huge tensioners like tractor treads squeeze the pipe to hold it or let it out. The pipe appears to move through the firing line and then into the sea, but it's really the ship creeping forwards as new pipeline is formed on board. The Solitaire will have to work around the clock to complete the pipeline on schedule. This is the deepest pipeline she's ever laid, but her biggest challenge is yet to come. She will also have to install a massive T-assembly, a connector that will allow future pipelines to link to the Independence Trail. Welding the large spigot-shaped T into the pipeline shouldn't be hard. The difficulty will come in trying to push the bulky structure out of an assembly line that's been designed for pipes. The crew has a plan, but it's risky. Work on the Texas coast reaches fever pitch on the final part of the project, the Independence Hub. This huge floating platform will process all the gas from the project's 15 deep-sea wells and then send it 217 kilometers to shore along the Independence Trail. This megastructure will soon be towed out to the gas field, but first it has to be completed. The hub is made up of 2 parts, the upper unit or processing platform and the lower unit, a hull to keep the hub afloat. The massive platform will process 28 million cubic meters of natural gas each day, enough for the cooking and heating needs of 5 million US households. When it's done, it'll be the heart of the largest gas processing project in the Gulf and the deepest anchored platform in the world. The team needs to join the upper and lower units together. Just outside the harbour, another mega mover arrives, the mighty Servant 3. She's carrying the massive flotation hull, the four-towered structure on which the platform will rest. The mighty Servant has brought the hull all the way from Singapore, where it was built, an incredible 16,000-kilometre journey. Now she needs to offload her cargo, and she does this in a very unusual way. Huge ballast tanks inside will slowly flood, causing the ship to settle 2 stories lower in the water. Once this is done, tugs will pull the hull free. It's a simple process, but a dangerous one. Both the ship and its cargo could quickly become unstable. And the huge towers of the hull could catch the wind like sails. In a strong gust, the hull could sway, crushing anything in its path. Conditions have to be perfect, and that's not what Mother Nature has in mind today. Back out in the Gulf of Mexico, the Solitaire is about to tackle another critical part of the Independence project. She's already laid several kilometers of pipeline for the Independence Trail, which will bring processed gas to shore. Now she has to install a massive T so that future pipelines can also attach to it. First, workers must weld the T into the pipeline. But there's a problem. The joint between the pipeline and the T has to be lined up perfectly, and the tool used to align the joint has become jammed inside the T, bringing the entire operation to a screeching halt. While the rest of this massive factory waits, engineers scramble to free the alignment tool.
Since you can't pull it by hand, we're going to put a winch on it, pull it on through. Bust that one around up like that.
The combination of a chain hoist and manpower finally does the trick. The Solitaire is back in business, and the T moves down the firing line. But this is when the operation gets dangerous. As the pipeline exits the Solitaire's hull, its weight is borne by 3 powerful clamps called tensioners. These hold the massive strain of nearly 3 kilometers of pipeline as it hangs between the ship and the sea floor. But to let the huge T pass, the tensioners will have to be opened one at a time. This means that the weight of the pipeline, all 590 tons of it, will be shifted to only 2 tensioners. If one fails now, dozens of meters of pipe will whiplash through the ship and down to the sea floor. The Solitaire starts to move the T through the firing line. The first of the 3 tensioners opens. All eyes watch as the T inches forwards. The other 2 tensioners strain under the load, but they hold. Twice more, a single tensioner opens and the entire strain of the pipeline is held by the other 2. Finally, the T is on the far side of the tensioners, on its way to the bottom. It's a major success for the Solitaire, bringing the ship one step closer to building the pipeline on schedule. Back on the Texas coast, the huge gas processing platform and the hull that will float it have to be joined together. But first the team has to get the hull off the mighty Servant 3. This mega cargo ship offloads by sinking and letting her cargo float. For the last few hours, a strong breeze has made it too dangerous to move the hull, but finally the wind has died down. Now the tricky business of sinking the mighty Servant 3 begins. The hull's massive towers jut up like 4 huge sails, and every time the wind kicks up, the massive structure strains against the mooring lines with tons of force. On the bridge of the mighty Servant, the captain carefully controls the flooding of the ballast tanks. Over the next 10 hours, his ship slowly sinks into the harbour. Finally, after its globe-crossing journey from Singapore, the hull is afloat. Now it's time for a mind-boggling lift. The gas processing platform is more than 70 meters wide and weighs over 8,000 tons. It has to be hoisted 60 meters into the air and then strategically lowered onto the hull support pillars. And there's only one machine for the job. This is a heavy lift device, or HLD, one of the largest of its kind in the world. The first step is to slide the topsides along the skidway and onto this barge. This takes 2 huge winches and a little grease.
These men in the white overalls are applying the grease on top of the Teflon skidway. We call it pumpkin wax. It's kind of pumpkin colored, but it's gooey, it's sticky. And my wife says every time I walk by it, it attaches itself to me.
The winches turn, and the 7-story platform begins to move. At the water's edge, the process gets trickier. Water in the barge's ballast tanks has to be carefully adjusted to accept the massive weight. It takes 8 hours, but finally the platform is on the barge. Tugboats wrestle the platform into position underneath the HLD. Then the crew attaches huge A-frames to lift it. But high winds kick up again. In these conditions, lining up the hull perfectly under the platform will be almost impossible.
We need to make sure that the hull is in the appropriate position when we stab down, because we only have a 3-inch tolerance when we stab down, and that hull has to be in a perfect position.
For now, the operation is on hold, but that won't slow down another mega mover. Out in the Gulf, preparations to complete the hub's final home are underway. Keeping the enormous Independence hub secure in the Gulf's stormy seas will require heavy-duty anchors and a special ship to install them. This is the Boulder. The columns of her pontoon-like hull make her incredibly stable, essential for lifting the huge anchors that will secure the hub to the ocean floor. With her massive open deck, she looks more like a platform herself than a ship. If the Boulder doesn't install the anchors perfectly, the Independence hub could pull free. That's what happened to this hub. Thunder Horse was the biggest hub in the Gulf until Hurricane Dennis ripped it from its moorings. To make sure the same thing doesn't happen to the Independence hub, engineers are installing 12 permanent anchors called suction pilings. A 4-kilometer long cable will connect each piling to the floating hub. The boulder's challenge is to place each piling in exactly the right spot and perfectly level, nearly 3 kilometers down. If she succeeds, these will be the deepest pilings ever installed. She needs her cranes, some of the most powerful afloat, to achieve the task. Together, they're able to lift 6,300 tons. But this job doesn't just require brute strength, it also needs precision. The boulder's 7 engines help to keep the ship on target. And staying in position is the name of the game when you're installing pilings this big. Each one weighs over 180 tons and measures 26 meters long and 5 meters in diameter. Securing them is a process that necessitates perfect coordination of the cranes, the engines, the winch, the remotely operated vehicle, and the crew on deck. Barges bring the pilings to the ship. Then cranes lift them on board and set them down very gently. The crew attaches a harness and chains for the lift. It's a very big and very dangerous maneuver, requiring the biggest shackle on board. The crew checks every centimetre of the shackle, as even the slightest flaw could lead to disaster.
What he's doing, he's looking for microscopic cracks in the surface of this shackle that might grow to a critical size when it's highly loaded during lift. If that were to happen, the shackle could fracture and we could have a real disaster on our hands.
The 2 cranes lift the piling and turn it on end. The procedure goes without a hitch, and the piling lowers over the side of the boulder. Back on the bridge, the crew monitors every movement. If the boulder isn't level, or if she begins rocking, the huge piling could essentially become a wrecking ball and crash into the deck or punch a hole in the ship. Despite all that weight over one side of the ship, it doesn't tip over because workers back on the bridge control the ballast tanks in the boulder's hull to counteract the weight. The piling lowers into the sea. Then, with a blast of escaping air, it's on its way. On a 4-hour journey nearly 3 kilometers into the depths. The huge anchor has to be placed within a hair's breadth of a buoy, set on the ocean floor, and at the right angle. Wind isn't a problem now, but currents are, and the boulder's engines strain to steady the ship. If the piling isn't installed perfectly, the massive tension of a 4-kilometer mooring line could rip it apart. The piling hangs just centimeters from the ocean floor. What the crew has to do now is truly incredible. From the surface, they must precisely place the piling on the sea floor. ROVs are the eyes of the project engineers, allowing them to inch the massive piling ever closer to its target. The crew will have to get it just right if the pilings are to be ready when the Independence hub arrives. The boulder inches closer to its target, ready to install one of the dozen pilings that will anchor the Independence hub at the center of the gas field. They make the drop, and 180 tons of piling stab into the sea floor.
Does anybody have a visual on draft readings?
The piling's weight drives it an incredible 13 meters down. It's in the right place, but is it aligned properly?
Orientation is very good. Probably about the best we've achieved thus far. It's very good.
Tightest one we've had.
Hey guys, how's it looking?
The ROV moves in for step 2. It closes the valves that seal the end of the piling. Then it connects a powerful pump. As the pump sucks out the water inside the piling, the structure sinks even deeper into the sea floor. The mission is finally accomplished, but the Balder's crew doesn't have time to celebrate. They'll need to work around the clock to install the remaining pilings before the hub arrives. Construction of the Independence project is almost complete. The 15 wells, 350 kilometers of pipelines, 190 kilometers of control cables, and 12 mooring pilings are nearly ready for the arrival of the Independence hub. In Texas, meanwhile, it's time for the big lift, the last obstacle facing the project engineers. They need to hoist the nearly 8,000-ton processing platform onto the 4 towers of its behemoth flotation hull. It's a job for one of the biggest lifters in the world, the Heavy Lift Device, or HLD, but it's never attempted a load this large. Inside the control shack, engineers continuously monitor the HLD's controls in preparation for the big lift. Its mammoth booms are 150 meters long, and 37 kilometers of cable weighing 800 tons run through her motors and winches. Sensors on the booms and cables provide constant feedback to the engineers. On the hub and the barge, workers perform their final checks. Then all but a few crew members move off to a safe distance. A broken cable now would send the mammoth platform crashing to the ground. The lift's motors begin to turn. The cables take up the enormous weight. Then an ear-splitting boom gets everyone's attention. A fitting for the A-frame has simply adjusted under the strain. The lift continues. Cables strain as the HLD takes the full weight of the platform. Then suddenly, one side is free. In the control room, every sensor is double-checked. The motors and winches turn, and the 8,000-ton platform hangs free. But the biggest challenge is still to come. Setting the suspended platform onto the 4 points of its flotation hull. First, the platform has to be raised even higher to make room for the hull. Then, 4 tugs will work in concert to turn the hull and push it into place. On top of the hull, an alignment pin will help to ensure perfect contact. The hull has to be positioned precisely so that the pin fits inside a 61-centimeter diameter guide.
10 feet height from the guide to the...
It's now up to the team leader to thread this needle and mate the platform to the hull.
When yours line up, if you get there.
Thick steel mooring cables connect the hull to shore, controlling the critical position of the hull underneath the platform. The team leader communicates constantly with his spotters on the hull's towers.
I'll put you in the guide.
Put a swing. Easy boom up with a easy swing.
He directs the massive platform to come down.
Twist.
With only 8 centimeters of tolerance, it has to be perfect.
Yeah, 10-4. I don't need quite a foot to get in the guide, but
but the alignment is off.
It's turned just a hair.
If the team continues, the stabbing pin will hit one side of the guide and the platform will miss its connecting points. The team leader calls for the mooring cables to be adjusted.
All right, Larry. Booming down on the south.
The platform eases down further. One side makes contact.
Boom the north down.
That's you back there, JJ.
But the other three corners aren't matching up.
All right, swinging back and forth out there.
Asteroids, yeah.
Asteroids.
We're booming down with the north boom to take the twist out of the module.
Engineers in the control shack lower one of the HLD's booms. The platform continues to move down. Eventually, the four corners of the platform line up perfectly with the towers of the hull.
He's right on the money this time.
The Independence hub is finally complete. It's a landmark moment in the most ambitious deep-sea construction project ever attempted. Soon, the team will tow the hub into the Gulf and link it to the vast network of wells, pipes and cables already there. It's the jewel in the crown of the world's deepest natural gas network. And within a year, the Independence hub will be delivering 28 million cubic meters of gas each day, thanks to this team of amazing mega machines.
MegaStructures discovers the mighty machinery of the Panama Canal at the same time tomorrow. Next, it's brand new, Situation Critical.